what? More light. Somebody else. Organic matter. You already described it.
One more. Let him do it. He's doing it. Oh yeah, 2 pages.
You can decide on that in your group. Based on what we found when we did the experiment with the last group, it needs to be a little more. I would say probably 10 drops. If there are 3 of you, maybe you could do 3, 3, 3 and make it 9, or you could do 4, 4, 4 and make it 12. Somewhere in the 10 to 12 range. It's these two, so go ahead and do 12 drops, because that means you can put 4, you can put 4, and you can put 4. Yep.
How many drops?
For 12. You put 12 in each one. And then for those of you who've never used a dropper before, you squeeze, you put it in, let go, and it sucks it up. But a lot of when we worked on this yesterday with another group, a lot of people didn't know how to do it. So you squeeze, put it in, suck up. Exactly. Okay. And now, the solution that you're going to be putting in is peroxide. Have you ever used peroxide before? Yes. Where have you seen it used? On your knees. On your knees. Yeah. And what happens? You put it. You clean your ear with it. What happens?
It starts to bubble.
Never used it? Okay, so let's listen so you know what happens. Well, if you put the peroxide on your wound, then what happens? It bubbles up. Yeah.
It gets all the bacteria out when it bubbles up.
Yeah, so you'll be able to see that you have germs because the bubbles of the peroxide bubble up. It looks all white. And you'll be able to tell that when you put it on the dirt too. So you put it on the different soil samples, the sand or the soil. 1 and 2, and then once you get down to the results, you're going to need to make a little chart so that you can put your results in, and then we'll be ready to rock and roll with our experiment. But it will kill the bacteria. Good question. It'll kill it, but it'll show you that it was there in the first place. It'll show how much is in there. And what we're going to do is kind of time it to see how long it bubbles. I'm going to set the timer for 2 minutes, and at the end of 2 minutes of observing each one, you should be able to tell how, at least have a general idea of how much bacteria might be in there. If nothing else, you'll be able to compare one soil sample to the other. 12 drops. Or so. Wait, I'll do it together, and I'm going to push the timer so we time for the same amount. All right. Hang on. Girls, can we have 2 of the droppers? Can we have 2? And then you'll be able to add more. But they only have 2. Did you get to Joshua? Did you get to drop some in last time?
Yeah.
Okay. So, you don't, wait a minute. Let's wait for Jordan to get some peroxide.
Wait, hold on.
Squeeze. There you go. Oh, let's get a little bit more. Squeeze it. Suck up. There. All right. Now it's time to get the soil on your bar. Get set. Go. And observe. You can put all of your whole dropper in there. And then get your hand lens and observe closely and carefully.
That's so
Everybody has plenty in there. Everybody has plenty. Now observe. Grab a lens. Do you see bubbles?
Yes. It's definitely bubbles. Okay, I think. Say what one right there. Yeah, that's a lot of bubbles. It's like that.
Let's watch it for the whole 2 minutes. It honestly does look like saliva. I can see where you would say that. So I guess it would be safe to assume that we have more bacteria.
So I got my correct. I said
We can watch and see what it does.
I said it's called soil.
It looks like it's continuing. Oh, one thing.
I went for soil.
Everyone stop talking for a minute. Put your ear down on it.
It sounds like Rice Krispies.
Sounds like
It does. hot rods that you put in your mouth when you open
No
your mouth.
bubbling. Okay, that's kind of funny. I don't know what stuff stays in this slide. That's put your hair in it.
Okay, we have 14 seconds to look at it. Stuff to the wet stuff stuffed in it. Don't touch it. What you think, Jordan? I think it's pretty cool, huh?
Lots of bubbles.
Okay. Now it's time to write down your observation in your results section that you made.
No bacteria.
You think it won't? You think so? Jordan has an interesting theory. She thinks that it won't stop until there's no bacteria left at all. It will keep bubbling forever. And I did a little research last night. I found out that when peroxide touches a certain substance that's either on your skin or in the soil, that peroxide is H2O2, and then when it hits that surface, it changes into water plus oxygen, O2. So it comes out to be H2O and then oxygen. It sort of separates the whole molecule up. And that's why you see the reaction there. All right, write in your results. And now, time for conclusion time. I want you to think. First of all, in your conclusion, first let's discuss. In your conclusion, first let's get, where's your hypothesis right? Talk about it. Was your hypothesis right? Hang on. It was right?
I think the soil have more bacteria because the rocks, then animals and worms get in it. And worms got a lot of bacteria in it.
Okay. So because there could be you said rocks in worms? Especially the worms, they make me think of, well, what are worms? Bacteria and worms are in the same category.
They're decomposers.
Decomposers.
Don't they clean the soil too?
What's that?
Don't they clean the soil?
They clean the soil. Well, certainly because they eat the dead things. It's true. The food that goes back into the soil makes it richer. So, what do you guys think? Brian asked, do decomposers clean the soil?
They don't clean it, but they make it richer. They make it richer.
Okay, so that's and how do they do that?
By eating them, they eat that stuff.
So
They make it richer.
So what could we conclude from this?
And going out of them is clean.
First of all, which kind of sand or soil would support more life in an ecosystem? Definitely. And what does the bacteria have to do with that?
There's a lot of trash in there. No, there's a lot of dead things and stuff that makes it richer. It's like humans.
What do you think, Steven?
Like they're inside the soil, like making it more like stuff.
You need to respect Steven. Respect Steven.
If they live in the soil, they produces food, and then when they produce food, there will be more plants for them to make more food for animals and more stuff.
What do you think, Jordan?
I thought it was sand.
Okay, well, what do you now? Do you think that you're right? And then why do you think that is?
Because it's kind of like the same reason.
Yeah, well, say it.
Because I see on Animal Planet that dolphins and other animals get killed in the ocean while they're in it.
Right.
That's why I thought.
Well, that's no. Okay, that I completely understand your logic about why you thought it, but now why do you think you were wrong in this case?
Because this one's not bubbly, this one is.
Yeah. And now let me also give you this little bit of advice too. That if I found sand right from the beach, there probably would be more bacteria in it, but this sand came from a sample bag of like clean sand. So it would be probably even a better experiment if we were able to get to the beach, get some beach sand, and test it. But even so, like if we went and we got this, but the potting soil also came from a bag of potting soil. So that kind of keeps it more controlled. So we have both, sand from a bag and soil from a bag. And either way, that keeps both of those more like the same type.
But the sand could get bacteria.
Now we could.
Like they touch.
Sure, absolutely. And if we could go to the beach and we could get a sample of soil, and then if we go to a forest and get a sample of sand and the soil, we would still have similar results.
Bacteria.
Yeah. All right. So now.